Hopefully you all know who I am by now. If not, my name is Juliana, and today I will be presenting my independent research project for this semester's Stream Ecology course. The title of my project is Characterizing the Lateral Foraging Patterns of Bats at Hospelika Creek. The goals that I outlined for this project were to gain a better understanding of the distribution of bat foraging patterns as they relate to the possible food resources that are provided to them by streams. And specifically, I intended to focus on the effects that an increasing lateral distance would have on the number of observations of bat foraging activity. So the main question that I set out to answer through this study was, how do the foraging patterns of bats change as observation points are moved farther away from a stream channel? And I hypothesized that because the greatest likelihood of the highest density of emergent aquatic insects would be closer to the stream channel, that the sites that were closest to the stream would be the sites where I would record the most number of observations of bat foraging. So before I get into the methods and the details of my study design, I want to talk a little bit about bats and how they relate to streams, as well as why it's so important for us to understand the relationship between bats and their natural environments. I found several papers that outline the economic importance of insectivorous bats, but specifically in a paper written by Boyles et al. In 2011, the authors suggested that one colony of 150 big brown bats in Indiana consumes like an estimated amount of 1.3 million insect pests a year. Those same authors suggested that insectivorous bats contribute nearly $23 billion a year in agricultural pest control, which makes them pretty much unparalleled in that sense. And although we in this class may not be farmers ourselves, we rely on the agricultural sector of this country to supply us with the egregious amount of food that we as a population consume. So by proxy, that makes insectivorous bats important to us as well, even if they are just a means of agricultural pest control. I also read several papers that outlined the distribution of bats as a function of the availability of viable food sources. And in one paper written by Hagen and Sabo in 2011, they focused pretty heavily on the importance of emergent aquatic insects as a determining factor in the distribution of insectivorous bats. So not only is the availability of food and water from a stream an important component of the relationship between bats and streams, the open area above a stream channel also serves as an important means of unobstructed flightways, as well as a better area for communication for bats. I'm pretty sure we all know that bats communicate using echolocation. So those high frequency sounds that they emit travel better and more efficiently in areas that are open and where there are not as many physical impediments. So above a stream channel, as opposed to in forested riparian area or the floodplain on either side of a stream, is best when bats are detecting and capturing prey as well as communicating between individuals. And in this time of rapid land use alteration, it's vital for us to understand the relationships between the species that we rely on and the natural environments that they rely on, so that we can do what we can to preserve and protect, or even construct an environment that is conducive to those species. It's important for us to understand how bats rely on streams so that we can further foster this beneficial relationship between bats and us, because we determine importance based off of how our needs are met. And what would a presentation about bats and streams be without a few pictures of bats? Unfortunately, in my study, I was not able to collect my own pictures because I performed my samples in the dark. And also bats are very fast, and I just don't have that kind of sophisticated equipment. So I am going to show you just a few pictures real quick of some of the most common insectivorous bats in Alabama, which is where my study was performed. So up first we have the big brown bat, which is likely the most common species of bat, insectivorous bat, and probably just bats in general, in Alabama as well as Georgia. We also have the very cute evening bat. This bat's commonly mistaken for the big brown bat, although it's not as common as the big brown bat, but an insectivorous bat species nonetheless. We also have the Brazilian free-tailed bat, commonly called the Mexican free-tailed bat. It's another species of insectivorous bat that we see here in the southeast. And lastly, we have my favorite, possibly the cutest bat that exists, the eastern red. Very handsome, also very elusive, just a fun little guy. So my study was an observational study that was performed at Hospalaika Creek in Lee County, Alabama, where I live. Hospalaika Creek is a first-order tributary that flows to Little Uchi Creek, which flows to Uchi Creek, which flows to the Chattahoochee River. I performed time samples for all of my sampling nights, starting at 8 o'clock p.m. and ending at 9 o'clock p.m. Eastern Time. And I chose this time because bats are typically the most active in their foraging activities in the first 3 hours after dusk. So I tried to choose times that were late enough where I would see bats, but early enough that I would still be able to visually see bats. I had access to approximately 300 to 350 meters of land within which I could access the stream channel. So I established 3 general sites within that area, and I made sure that there was at least 100 meters in between the general sites to ensure that they were separate. I then subdivided those 3 general sites into 3 sampling subsites, and that gave me a total of 9 sampling sites. I only performed 1 night of sampling at each of those sites, so I ended up with a total of 9 samples. For this project, I chose to quantify foraging as the number of bat passes through an overhead 10-meter diameter. It's also probably important for me to note that foraging is typically quantified using sophisticated echolocation recorders. However, despite my desperate pleas, my family refused to foot the bill for an Anabat monitor, and I was forced to use my eyes. These are some photos of how I would set up my sampling locations. So the flag would be planted at whatever subsite we were working at in that evening. You can see the photo on the right, my lovely assistant, who I endearingly call Mother. We would take field tape and measure out 10 meters with the 5-meter mark at the flag. And then we would place our chairs at the ends of that 10-meter tape. We would then rotate that 10-meter tape so that it was long ways in between us. And we would leave the tape there. You can see, like in the photo on the left, we would leave it there, and that gave us a good general idea of the 10-meter diameter that we were working with. So if we saw a bat that flew through that approximate 10-meter overhead diameter, we would count it as a foraging activity. And if we saw a bat but it didn't fly through our 10-meter diameter, we would not count it. I think it's also important for me to once again clarify that we were not attempting to distinguish individuals. We were just counting the number of passes that a bat would make through that 10-meter diameter that we had established. It would be impossible for us to distinguish individuals, and it is very likely that we counted the same individual multiple times, but since we were trying to quantify foraging activity, it worked. So like I mentioned in a previous slide, we took those 3 general sites and subdivided them into 3 subsites. Those subsites were determined based on their distance from the stream channel. So each general site had a subsite at 5 meters, one at 15 meters, and one at 25 meters. The general sites were established in areas that had similar vegetation, which wasn't very hard to do since I only had access to about 300 meters. and it pretty much had homogeneous vegetation throughout. And I set out to perform my samples on 9 consecutive nights. However, I could only sample in nights with similar weather conditions, so I wouldn't go out in the rain. And in order to minimize the effects that that would have on my samples, I assigned the subsites values, and then I used a random number generator to randomize the order of my samples. I do have my camera turned off for this slide because I want you guys to be able to see all of the pictures. These are pictures from the 3 general sites that I established during this study. The top 3 pictures were taken with my back facing toward the stream channel to show you the whole site that was sampled. You can see that all of the sites are just pretty much grassy land with a small pine woodline at the farthest end. We were closer to that woodline in Site 1 than we were in Sites 2 and 3. Site 2, a little bit closer than Site 3, but definitely we were the closest in Site 1. That picture was taken at the 25-meter subsite, so we were probably about a meter or 2 away from the pine trees as opposed to the farther distances that we were at Sites 2 and 3. The bottom 3 pictures show the stream channel at each general site. So unfortunately, I was only limited to the right bank side of the stream. I could not cross over to the left bank side, but you can see that the right bank is pretty grassy with some small shrubby vegetation. The left bank has more woody vegetation. Following my 9 nights of sampling, I took the data that I collected and I put it in the latest edition of JASP to create a contingency table in order to summarize the relationship between the distances that I sampled at all 3 of the sites that I established. A chi-square test was performed on this data, and you can see that I came up with a pretty large chi-square value, which indicated to me that there was a significant correlation between the distances that I sampled at each of the sites. I also elected to show the percentage within the row for the different distances that I sampled, and it was interesting to me that it seemed like most of the observations that I made for each of the distances were recorded in Site 1. So I continued to run chi-square tests. I aggregated the data for my sites as well as the data for the distances, and I wanted to see if there was a significant difference between the sites as well as a significant difference between the distances that were sampled. The chi-square tests for the site data and the distance data were run using Microsoft Excel. And this is a slide that shows the number of observations recorded from the different sites. And it shows that there was a very significant difference, and most of the observations were recorded in Site 1. This is a graph showing the difference in the number of bat foraging observations that were recorded at the 3 different distances that I sampled within. And you can see that this test was also significant, and that a majority of the bat foraging observations that I recorded across all 9 samples were recorded at the 15-meter site, as opposed to the 5-meter site, which was closest to the stream channel. If you can remember from the beginning of this presentation, I hypothesized that I would find the greatest number of bat foraging observations at the site that was closest to the stream channel, which would have been subsite 1 at 5 meters from the channel. However, my hypothesis was not supported by the results of this study, and I found that bat foraging activity was actually the greatest at the intermediate site, which was at 15 meters from the channel. I came up with a few possible reasons that this might be true. One of them was that insectivorous bats don't feed on emergent aquatic insects alone. So it could be possible that there was maybe a preferential mix of terrestrial and aquatic insects a little bit farther from the stream channel, and maybe that was a more preferred source of food for the insectivorous bats located at this site. It's also possible that there were less obstacles for prey detection I know that on the right bank of the stream channel, there, was some grass and some small shrubby vegetation. However, it was wide open on the right side of the channel, so maybe it was possible that because of that, the bats weren't limited to just the open area above the stream channel, and there were greater opportunities for foraging even farther from the channel. I also took into account the fact that at Site 1, where I saw the most observations, we were in close proximity to that wood line, and bats, some species of insectivorous bats do use old pine trees under bark, in trees, or in hollowed out trees as roosting areas. So it could be possible that maybe one of the reasons that I saw more bats in Site 1 than the other sites was because I was closer to the trees that they could use as daytime habitat. However, the results of this study do suggest to me that there is the possibility for future studies, maybe even perhaps a characterization of the longitudinal patterns of bat foraging. And a future study along those lines could be supported by the significant differences that I found between the sites. So to wrap everything up, I intended to use this study to better understand how the foraging patterns of insectivorous bats change in response to an increasing lateral distance from a stream channel. And although my hypothesis was not supported by the data, there were still some significant differences that I found between the general sites, as well as the increasing observation distances within those sites. And like I mentioned previously, the results of this study could lend to future research concerning longitudinal variation in insectivorous bat foraging. And overall, this was an extremely fun and interesting study to perform. Before I end this presentation, I do want to acknowledge a few people who helped me tremendously along the way. First of all, this would not have been possible without Larry and Loretta Wood. They are close family friends of mine who granted me access to their land so that I could access the stream channel. I also could not have done this project without the help of my mother, Stephanie Giles. She accompanied me on all of my sampling nights and helped me carry things to and from my sites every night. And I also want to thank Dr. Keller really quick for enduring my 1 million emails and questions and for being so willing to help no matter what. This is a list of references that I used throughout the scope of this study. They helped me generate my project proposal as well as the methods for this project, and just generally aided in understanding the results of my study. Thank you all for your attention, and I will take any questions if you have them.